Hello everyone and welcome to the Modern Java course. In this final installment on Manifold, I will cover support for graphical, integrating JavaScript and the preprocessor. All of these are important for different reasons. Graphical is used by multiple sites including Shopify and Facebook. We need to support that style of API, but it's very hostile to static languages like Java. Thankfully, Manifold removes some of the rigidness of Java and makes graphical usable. Integrating JavaScript seems redundant, but in some cases we're required by regulator to have the exact same algorithm in both the client and the server. Literally the same code. This can solve that. A preprocessor is terrible until that time where you actually need it. There are better alternatives for most cases, but often not as simple. Before I proceed, as usual, the code for this and the other videos in the series is available on my GitHub page, so check this project, start it, and follow me on GitHub. Some of you might be familiar with Graphical. Since it's only 8 years old, it's essentially an alternative to REST. At its core, Graphical is a specification that defines how to request and manipulate data between client and server. Unlike traditional REST APIs, which requires loading from multiple URLs, graphical APIs get all the data your app needs in a single request. Here we have a typical REST API, client and server. Simple. When the client wants data from the server, it sends a request to a determined URL with a predetermined parameter and the identity of the element we want. Something of that sort. We generally invoke an API and expect a response. When we get back a response which includes all the data we want, but this has some problems. The developers that built the server don't know what I want. They serve many clients, mobile, web, other companies. They return a lot of extra data and also not enough data, forcing me to do multiple round trips to get the additional data I need. With Graphical, this changes. We pass a special request to the graphical URL, and it's a bit like an object database query. It defines the fields we're interested in. The response only includes the object graph that we care about. This is obviously problematic in a language like Java, where a response object will typically include all the fields as the language isn't dynamic. This is a snippet from the GraphQL sample in the Manifold project. It includes multiple GraphQL files we can use to determine the API queries we can make. Without generating any code, we can run a media query with that code against the endpoint. Notice that a builder pattern is used and it includes the optional arguments for the query. We can then iterate over the list of movies and extract any data we want. This is very similar to our JSON discussion from the first video. During my consulting years, I worked with some banks, and one of the reasons they picked Java was that it fit with regulatory needs. They could do interest rate calculations in the Swing UI and in the EJB backend with the same code. That way they knew the result would be similar. There was a major lawsuit about fractional rounding in that industry in the past, and it didn't end well for the bank. Unfortunately, most of the front ends are in JavaScript now. How can we have the same result in both sides, or at least verify that JavaScript returns the same result for debugging? Manifold lets us place a JavaScript file is in the project. This is a simple interest rate calculator I got from Stack Overflow. I placed it in the source directory next to the Java code. Thanks to Manifold, I can use it like this. Calc is the name of the JavaScript file. We can also use JavaScript classes like this pretty seamlessly. Under the hood, this uses Rhino to run JavaScript, so it isn't cross-compiled to Java or something like that. When I started learning Java, I was shocked it was missing a preprocessor. How do you write conditional code? As I worked with this, it became obvious. You use if. Since Java is portable, there's no platform-specific code. Since it's jittered, it can remove the underlying code entirely. There's no need for a preprocessor, but in reality, there sometimes is. We sometimes want to build something a bit differently when running on-prem and in the cloud. In that case, configuration might not be enough, since our code can be reverse engineered. There are ways around it, like libraries that are included differently and various build tricks, but these aren't simple. We can define a value like this in the build properties file in the root directory. Notice the lack of value. We don't need that for a preprocessor, it's just a key. We can then write code like this to run the right version of the code and fail if the definition is missing. We can also define via environment or via compiler arguments. There are many built-in values such as the version of Java, etc. I'm not sure if that's the best way to build an application though. I didn't cover everything in Manifold, but I came pretty close with most of the big ticket items. I hope you found the subject interesting as I have. If you have any questions, please use the comment section. Thank you.